Good morning, guys. And today is March 31st, and we're writing exponential functions today. All right. So, the definition of what an exponential function is: a function of this form, f of x is equal to a times b raised to the x. Okay. B has to be greater than 0. So, b is always going to be positive, and b can't be 1. And there's some typos in here. Okay. And a is greater than 0. That's not true. Okay. So, let's cross this out. So when it takes on this form with b greater than 0, b can't be 1, that's an exponential function, okay, with base b and then coefficient. Let's cross this out too, okay? So the period should end after there, okay? All right. Sorry, I printed these really fast and there were some typos, okay? So a function fx equals a times b to the x. B has to be greater than 0. B can't be 1. That's an exponential function, okay? If b is greater than 1, then what we have is called exponential growth, and it's growing, okay? If b is between 0 and 1, then what happens is the function decreases, and it's called exponential decay. All right. So right now, you guys are seeing a curve that looks like this with the coronavirus. Okay. It's growing it's sort of exponentially. It's not quite an exponential function, but it's growing like this right now. Okay. We're watching it in California doing this. Okay. Growing the number of cases and the number of people that are testing positive for it. Okay. So this kind of deals with the what's going on in the world right now. Okay. So it's kind of interesting. Okay. All right, so that's an exponential function, and let's just get to our first example and use the given information to write some functions here, okay? All right, so for example number 1, we're given that f of 0 is equal to 4 and f of 1 equals 6, and we want to find values for a and b and write the exponential function f of x equals a times b to the x, okay? So what we have is this 0 is an input, so this is an x, and this is the output y, right? So I know when I put 0 in for x, I'm going to get out 4. Well, here I know when I put in 1 for x, I'm going to get 6 out, okay? Because that's my y, all right? So over here, if we use this f of x equals a times b to the x, I know that the function value is 4. So I'm going to write 4 is equal to a times b to the 0 power. Okay, now how do I know it's 0? Okay, because that's where my x is, right? So I know when x is 0, I know my output is 4. So there's an equation here, right? But the thing is, we have two unknowns. We don't know a and we don't know b, right? So what we have to have is another equation with a and b. That's why I have to give you another piece of information here, okay? So what this means is that 6, our output 6, right, has to come from a times whatever the b is raised to the first power, because now our x is 1, okay? Now from over here, b to the 0, b has to be greater than 0, all right? And so since this can't be 0, okay, b to the 0 has to be 1, okay? So any number other than 0 raised to the 0 power is always 1. So this is going to be 1. So we have 4 is equal to a times 1. Okay, so now what's a times 1? Well, that's just a. So I now know what my a value is. My a is 4. Now, how am I going to get the b value? Okay, so right here is my a, right? And I now know that a is 4. So I can do a substitution. I can replace this a with what I know it is, which is 4. So 6 is equal to 4 times, and b to the first, well, b to the first is just b, okay? So then to solve for b, I just need to divide both sides by 4, and I have 6/4 is equal to b. Now, that's a correct answer, but it's not the best answer, right? Because both of these are divisible by 2, so that means b is really 3/2. Okay, and this number is positive, right? It has to be positive, and since it's bigger than 1, because 2/2 is 1, so 3/2 is bigger than 1, then we know we have exponential growth, okay? And we can now write our function, okay? So f of x is equal to our a, which is 4, times our b, which is in this case 3/2, raised to the x power. And that's how you write an exponential function. Okay, for this next problem, example 2, given f of -1 is 8 and f of 2 is 1, find the values of a and b. So this one's going to be a little bit more work, okay? But what I know is if I put -1 for this x right here, I know f of x, right, is going to be 8. So I'm just going to start with that. So I know 8 is equal to a times b to the -1 power, okay? I also know, and this is, okay, I should say this. This is an equation, and I have two unknowns. I don't know A and I don't know B. When you have two unknowns, you need a second equation. So however many unknowns you have, that's how many equations you're going to always need. It doesn't matter if it's exponential or not. That's how we solve multivariable equations, okay? The number of variables that you have to solve for is the same as the number of equations you need, okay? So here, we need another to write another equation. This is going to allow us to write another equation with a and b. So I know if I put 2 in for x, I'm going to get 1 out. So that means I have 1 is equal to a times b squared. All right? Okay, this one we can rewrite a little bit differently. Okay, so now I have 8 is equal to a times, and b to the -1. Well, b to the -1 really means 1 over b. So I'm going to write this as 1 over b. Okay, and now we have a couple choices. Okay, you can solve either one of these equations. Okay, you can solve for either a or b and put it into the other one. All right, so kind of look at the easiest one. So I'm looking at this one. All right, this first equation, 8 equals a times 1 over b. I can solve this for a pretty easily, okay, by just multiplying both sides by b, okay? So that would result, if I multiply both sides by b, that would result in 8b is equal to a. So I don't know the exact number a is, but I know it's 8 times b, okay? So how does that help me? Well, back over here, okay, I'm going to be able to put this 8b in for my a right here, okay? All right. So what that means is I can write this instead. I can write this as 1 is equal to 8b times b squared. And then I can multiply these together because 8b times b squared is 8b cubed. So this becomes 1 is equal to 8b cubed. All right. And then I'm going to solve for b now, okay? Because this is just an equation with one variable, b. So I'm going to divide both sides by 8. So that gives me 1/8 is equal to b cubed. To undo cubing, I can cube root. So I'm going to cube root both sides. Okay, with odd ones, these are going to undo each other. So the right side is going to be b. Okay, and the cube root of 1/8, that's the same as the cube root of 1. The cube root of 1 over the cube root of 8. Well, what's the cube root of 1? Well, what could I multiply 3 times in a row, same number, 3 times in a row, that would give me 1? Well, it'd be 1. And what number could you multiply 3 times in a row to get 8? Well, it'd be 2, right? So I now know that my b is 1/2, okay? Now, I know what b is. This a was determined by whatever the value of b is. Well, now I know b is 1/2 from this equation, okay? So back over here, now I can come back and substitute this b with 1/2. So this is going to be 8 times 1/2, and that's going to be equal to a, all right? And all I did was I took this 1/2 and put it in right here for b, okay? Now, what's 8 times 1/2? 8 times 1/2 is 4. So now I know my a value is 4. So my function that I would write is f of x is equal to my a, which is 4, times my b, which is 1/2, raised to the x. Something that I need to point out, okay? When your base, all right, is a fraction, you must put parentheses around it, okay? Because this is not the same as this, okay? You have to put parentheses around the base when it's a fraction, okay? If it's just a number like 5, no problem. You don't need to have the parentheses. Can you put the parentheses? Yes, but you don't have to have them if the base is a number like 5. You only have to have the parentheses when it's a fraction, okay? Like 1/2 or 3/2, okay? All right, so that's example 2. Let's take a look at example 3. Okay, so for example 3, what I've done is I've given you basically the same information, but just in graph form, okay? So I've given it to you as a graph. Now, by looking at this, this is exponential growth because it's growing, it's increasing, okay? So what I want you to understand is that our b right here, because it's exponential growth, our b has to be a number bigger than 1, okay? For it to be exponential growth, our base has to be bigger than 1. To be exponential decay, our b has to be between 0 and 1, okay? That's all from the first page, okay? But we know our b is going to come out to be bigger than 1 in this case, all right? So what do I know? What's the information that's been given to us? Well, we know if we put 0 in, we get 10 out. So that's saying f of 0 is equal to 10. If I put 0 in, I get 10 out. I also know if I put 1 in, I get 20 out. So that'd be f of 1 is equal to 20. It's really always nice when our input is 0, okay? Because that means this exponent is going to be 0, all right? So right here, what we're going to do is it's the same thing, okay, that we've been doing for the last 2 examples, okay? What we have is 10 is equal to a times b to the 0 power, because I know if I put 0 in, I get 10 out. Over here, I know if I put 1 in, I get 20 out. So that'd be 20 is equal to a times b to the first power, okay? B to the 0 power, well, that's just 1 because we know b can't be 0, right? It has to be between 0 and 1 or bigger than 1, okay? So we know this is going to come out to be 1. So we have 10 is equal to a times 1 because b to the 0 is 1, all right? And then a times 1 is a. So 10 is equal to a. That's why this is nice when we have an input of 0 because we lose our b right off the get-go, okay? All right, so back over here, I know that my a value is 10. So this a right here, I can swap it out with 10. So that means 20 is equal to a, which I now know is 10, times b to the first, and b to the first is just b, okay? And now I can just solve this for b and divide both sides by 10, and I get 2 is equal to b. And that coincides with what I said earlier, is that we look at the graph and it's exponential growth. And to have exponential growth, our base has to be bigger than 1, and 2 is bigger than 1. So it works out, okay? Like if you got like 3/4 or 1/2 or something like that, you should know that you made a mistake because of the exponential growth, okay, from the graph. All right, so we can write our function now. F of x is equal to our a, which is 10, times our 2, right? Now, here's an example of you don't have to use parentheses. So you could write this as 10 times 2 to the x. Or, okay, you could put parentheses around it. F of x is equal to 10 times and then 2 raised to the x. And with the parentheses like this written, you wouldn't have to put the multiplication dot, okay? All right. So that's example 3. Okay, I'm going to go with example 4, where we have taken this exponential function and we've shifted it up or down. If you notice, exponential function, to be an exponential function, the horizontal asymptote is always at y equals 0. Okay, so if we shift it up or down, okay, then we're going to be adding or subtracting to this function. And that's the next example I'm going to talk about. Okay, example 4. So turn the page and we'll finish this up. Okay, for example 4, we're going to use the given information to write the exponential function of this form. F of x is equal to a times b to the x plus some constant c, okay? And we know f of -2 is 13, f of 0 is equal to 1. and we have a horizontal asymptote at y equals -3, okay? All right, so when we have this horizontal asymptote, a basic exponential function, all right, its horizontal asymptote is at y equals 0, okay? Now, because of this, we have actually shifted it down 3. So our C, this is C right here, okay? Whatever our horizontal asymptote is, that's our C value, okay? So automatically, I know what the C is, okay, just by reading this, okay, and understanding what an exponential function looks like, okay. So I know f of x is now equal to a times my b raised to the x, and this specific one, I'm going to add -3, but adding -3 is really just subtracting 3. So that's how I'm going to write it. I'm going to write it as -3. Okay. Now, I know from this that if I put in -2 for my x, I'm going to get out 13. So this is going to allow me to write an equation, right? Just like we did before. So this is going to be 13 is equal to a times b raised to the -2 minus 3. Okay, so that's one equation. It has two unknowns. I need a second equation, and that's where this comes in, okay? F of 0 equals 1. So I know if I put 0 into the function, I'm going to get 1 out. So that would be written in this form as 1 is equal to a times b to the 0 minus 3. Okay, so one thing I can do is add 3 to both sides on this one, okay? And you get 16 is equal to a times, and b to the -2 is really 1 over b squared. So I'm going to rewrite that as 1 over b squared, okay? And then over here working on, there's nothing more I can do on this side, okay? So I want to jump to the other side and start working on this one, okay? So I know that 1 is equal to a times b to the 0. Well, again, this b is, it's between 0 and 1 or bigger than 1. So when I raise to the 0 power, this has to be 1, okay? So I have 1 is equal to a times 1 minus 3, okay? That would be 1 is equal to a minus 3. Adding 3 to both sides, I get 4, and that's equal to a, okay? So from this, I now know my a is 4, okay? Now, back over here, okay, this a can now get replaced with 4, okay? So now I have 16 is equal to 4 times 1 over b squared, okay? So I want to show you this 4 I put in right here, right? Okay, so now I need to solve this equation. That allows me to write one equation with one variable that I'll be able to solve, okay? So this becomes, what I'm going to do is I'm going to clear out the fraction from both sides. So I'm going to multiply both sides by this b squared. So that gives me 16b squared is equal to 4, which means b squared is equal to 4 over 16, okay? And then to get rid of the square, I'm going to square root both sides. So the square root of b squared, I'm going to slide this up a little bit more, is equal to the square root of 4/16. Okay, the square root of b squared is the absolute value of b, okay? And the square root of 4/16 is the square root of 4 over the square root of 16, and that would just becomes 2 over 4. Now that can be simplified, and I'd want you to simplify it. So the absolute value of b is equal to 1/2 because both are divisible by 2. All right, now b can be equal to, solving this equation, plus or minus 1/2. But b has to be greater than 0, right? B has to be greater than 0. So it's not the negative one. It has to be b is equal to 1/2, okay? So we know our base now is 1/2, okay? We knew our a is 4. From the get-go, we knew c was -3. We can write our equation now, or our function, okay? And it's going to be f of x is equal to our a, which we now know is 4, times our b, which is a fraction, so I need to use parentheses, 1/2 raised to the x power, and then minus 3 because this got shifted down 3 because the horizontal asymptote is at y equals -3. Okay, and that's how you write exponential functions. Okay, I want to point out one problem. Okay, watch out on the homework for number 13. Okay, I thought about skipping it, and then I thought, no, go ahead and work it out and show what happens. Okay, so you may want to, if you get stuck because it's kind of a difficult problem, go ahead and look at the solutions, and you can understand like why I wrote what I wrote. Okay. All right, you guys. So let me pull up the calendar or the assignment sheet, and I'll show you that. Okay. So here's the assignment sheet. Okay. We did this on March 31st. Okay. And you guys, it's really important that you keep up on this work. Okay. If you're watching the videos and you guys are doing a good job, but there's a few of you that are choosing not to do this. And I just have to tell you, it's going to be really hard on you. You're just making it harder on yourself when you're not doing these assignments. Okay. So just in the future, okay, it's not going to affect your grade now, but it is going to affect how you do in the future, because there's a lot of higher level math and science classes that use logarithms and exponentials. Okay, especially those of you who are taking AP chemistry right now, like you could have used this lesson probably 3 or 4 months ago. Okay, all right, so you're going to use these in higher science classes. Okay, all right, so let's do assignment worksheet ELF 8. And you guys, I sure do miss you. So you guys take care, and I will see you next lesson. Okay, take care. Bye.